Hello everyone, welcome to Study Meet again. Today I will I will continue explaining about density, weight, and mass. So today we will learn how some methods to measure density in real life. For example, let's start with equipment list. So this is the table that shows the equipment and the purpose of this apparatus that you need to measure this density. You can pause this video and uh, try reading this apparatus. So resolution 30 centimeter ruler is equal to 1 millimeter in our experiment. Vernier calipers 0.01 millimeter, micrometer 0.001 millimeter, digital balance is 0.01 grams. This is certainties in each equipment. So for example, experiment 1, measuring the density of regularly shaped objects. The aim of this experiment is to determine the densities of regular objects by using measurements of their dimensions. So we have independent variable, the type of shape or some volume can be, but also we have dependent variable, is mass of object. So place the object to digital balance and to get its mass and write it down. You can use either ruler or vernier calipers, as mentioned in the above, to measure the object's the dimensions, because we need the object's this volume. So in the last lesson we learned how to calculate them. So repeat measurements and take an average of this reading. So we should calculate all this. We should measure all this and find densities, and we can take its average as our density. An example of results table might look like this. So here we are repeating this experiment for each 3 times, or you can do it more to make sure. And you can take its average as your result analysis. So these are the formulas that we learned in the last lesson. This calculating volume of each object, sphere, cube, and cylinders. So this might help you while converting from centimeters to meters. 1 centimeter is 0.01 meters. So 50 centimeters is 0.5 meters. So this was our formula to calculate this density, mass over volume. So now we have experiment 2, measuring the density of irregularly shaped objects. So again, we have independent variable and dependent variable. So now dependent variable is the volume of displaced water, and independent variable is the different irregular shapes and mass. So we will get one Eureka can and measuring cylinder. So now we will place this object onto the digital balance again and get its mass and write it down. Fill this Eureka with water up to point just below to this spout, and then we can place an empty measuring cylinder below its spout. As you can see, it's below its spout, and then carefully lower it into Eureka can. Measures the volume of displaced water in the measuring cylinder. Repeat these measurements and take an average before calculating this. So it's same as experiment 1, last 5, 5, and 6 things that we need to do. So you should repeat this experiment at least 3 times and take an average. Alternatively, the object can be placed in measuring cylinder containing a known volume of liquid, and the change in volume, then measure it. So as you can see here, it was at first it was some 24 centimeters cube, and then it became 31. So we can just subtract it so that we can find volume easily, so that we don't have to use any formulas. For example, for this stone, nobody knows how to calculate its volume exactly with formulas. So that's why we are using this method. So this would be your table. Would be how your table look like after doing experiment. This again, this formula. Experiments measuring density of liquids. Now we have our dependence variable would be mass of cylinders. So as you can see, we are firstly measuring this on a balance, electronic balance, and then we are filling it with water, so we can easily calculate its mass. So remember, 1 gram is 0.001 kilograms. So evaluating experiment. This is also one of the useful things, because there are systematic errors that are related to your equipment or some digital. It can be your digital balance would not be working properly, or your ruler might not have proper millimeters or centimeters. But also there are random errors. For example, while you are doing your experiment, for one, wind might blow. So this kind of errors are random errors. So that's why you can reduce random errors by repeating this experiment few more times. But for systematic errors, you need to be careful of using your this equipments, apparatus, and because if they are broken, your experiments would cause errors. So safety considerations: there is a lot of glassware in this experiment. Ensure it's handled carefully. Water should not be poured in a measuring cylinder when it's on the electric balance, because this can lead to electric shock. Nobody wants to get electric shock by doing experiments, so be careful. So now we will move on to the floating. So floating objects. So upthrust. What is upthrust? Upthrust is a power that pushes object upwards in fluids. It can be liquids or gases. So this is always opposite direction to object's weight. For example, now in the Earth, it's always upwards. This is why boats, as you can see here, boats and this is why boats and objects that are less dense than water float in the water, and denser ones that are more dense will sink. So the main thing is here. So we need to compare two things: the density of this object and density of the fluid. So if the object is more dense than the fluid, it sinks. Otherwise, it floats. So factors affecting float and sinking. So whether an object sinks or floats depending on upthrust. If upthrust of object is equal or greater than the object's weight, then the object will float. If the upthrust is smaller than the weight, the object will sink. The outcome also depends on object's density. If the density is less, if it has a density less than density of fluid, it will float, otherwise it will sink. So as you can see here, we have water density 1.0 in grams per centimeter cube. When it's converted to kilogram over meter cube, it's thousands, remember? So wooden block has 0.9, so it's floating. But iron block has a higher than density of water, so it's sinking. This polished So this polystyrene block has a lot less density than of the water, so it's not even sinking. It's part of it is not even sinking. It's absolutely floating. Polystyrene block will float in the water. This is because polystyrene has density of 0.05. This is much less than the density of water. Its wooden block has slightly less, but iron block will sink because it's much higher than the water. We have 30 seconds video about this.
Here's a question for us to consider, and we're going to start off by reading through it carefully to make sure we understand what it is.
So an object has a volume of 200 centimeters cube and a mass of 170 grams. A beaker contains water with density of 1.0. Discuss whether the object will float on the surface of the water or sink its bottom. So we had the density of formula mass over volume. So we will use this formula. We have mass 170. So we be careful. It's gram centimeter cube, and this is also gram centimeter cube. So we don't have to convert to anything. So we will divide it by its volume. So it's 0.85. So it's less than 1. Yes. So it's less than 1.0. So what does it mean? It won't float. It won't sink. It will float, but it will not float like polystyrene block, but it will float like wooden block because they have nearly same, and the water is also same density, but it would be much higher. So goodbye. See you in our next videos. Stay tuned for more.